Okay, today we're gonna talk about double bipoles. So, what's a double bipole? What are double bipoles? Well, a double bipole is a component with four inputs, which are also called poles, which is essentially a quadrupole, because quadri means four. So a double bipole. So a double bipole is essentially a quadrupole. Now, the poles are actually coupled two by two so that the current getting into one of the poles of a couple is the same as the current going out from the same couple. Let's write this. So poles are coupled two by two so that the current going into one of the pole of a couple is the same as the current going out from the same couple. So basically, so essentially the poles are coupled two by two and the current going into one of the pole of the couple is the same as the current going out from the same couple. Now, the couple of poles with this characteristic are gonna be called gates of a double bipole. So those are called gates. Remember that because I'm gonna use the word gates a lot in the future. Now, so we said that the couple with these characteristics are called gates. Now, the linear double bipoles with all the components that are linear are actually approximated models of real components that are actually not linear. Anyway, in the case of the resistive double bipoles, which not only are linear, but they don't even have a dynamic dependency with the time, we can have many different representation that are implicit and 6 different explicit representation, all defined with the electric, starting from the from what we have at the gates of the double bipole. Now, let's clarify this a bit because otherwise it's I do understand that the way I described it is kind of a mess. So let's just say, okay, let's just divide those into implicit, and we're going to have this, which is the implicit representation. So this is the implicit representation. And then we're going to have the explicit representation. So the implicit representation says that if we define a couple of vector with v called v1 of t and v2 of t, and I as I1 of t, times I2 of t, in which I didn't actually put the explicit dependency of time, but this is just to make, this is just to keep things simple. Now, the first it represents the tangents, so the voltages, and second the currents of the gate. So the first one is voltages of the gates, and second represents the currents of the gates. Okay, so the first one represents the voltages of the gates and the second represents the currents of the gates. Now, a generic linear relationship, implicit, so an implicit generic linear relationship which defines the double bipole is NV plus mu I equal to 0, which is actually very important. Now, M N is well, I'm just gonna call this N for simplicity instead of mu. Just gonna call this M because mu you expect some kind of constant. I'm just gonna call it N. So M and N are just an Rn times N matrix in the real matrix 2 by 2, and they're defined they're defined without a matrix, a constant matrix, which is actually multiplicative and not singular. But just think about them as matrix. While an explicit relationship, an explicit representation, which I'm going to express as a relationship, is, well, if M is not singular, then there is a matrix M minus 1, and we can actually write V equal to negative M minus 1 and I equal Ri. And of course, for I, we can just say, okay, I is negative n to the negative 1, mv equal gv.